Hi, we are going to learn about the Pythagorean theorem today, and this basically pertains to right angle triangles. And there is a basic measure to calculate the length of each of the sides of the triangle. So, basically, in this theorem, we have these two lengths, and these two lengths, when I add the squares of this length and the square of this length, it gives me their sum gives me the square of this length. Okay, so basically, let's say this is A, let's say this is B, let's say this is C. So based on the Pythagorean theorem, we have A squared plus B squared is equal to C squared. All right. So basically, if I am doing this and I am putting a perfect square here, this square plus this square equals, when I add them up, that's looking more like a rectangle, but when I add this up, if I do this square plus this square equals this square. All right, so let's put some values to this just to figure out what this basically means. Let's say this A is equal to 3 and B is equal to 4. We are going to see what the sum of these two squares are, and that is going to be what this is going to be. All right, so this basically means this: 1, 2, 3, right? And this means 1, 2, 3, 4. 1, 2, 3, 4. So that means this is 1, 2, 3, 4, 5, 6, 7, 8, 9, because 3 squared is 9. And this 4 times 4, 4 squared is 16. That's what we are going to get. So it's telling me that 9 plus 16 will equal this side, which is going to be 25. Okay, so this is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's basically, so this is basically nothing but 5. All right, so 3 squared plus 4 squared should give me 5 squared. So let's go ahead and just do the math calculation, where I had said the formula was A squared plus B squared is equal to C squared. And just check, we are going to substitute the value. This is 3 squared plus 4 squared. This should give me 5 squared. And let's see if that works. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. And yes, 9 plus 16 does give me 25. 25 is equal to 25. So this is correct. All right, because both sides of the equation have got to be the same. So now let's apply this. I mean, you have the basic knowledge of what this actually means. So now I'm just going to substitute the values and solve certain problems to help you understand this concept. Okay, so we know that 3, 4, and 5 are forming the correct equation for this. So let's try a few more. Once again, I'm just going to write the formula here. A squared plus B squared is equal to C squared. And I'm going to draw this out. This is a right angle triangle. Please remember that the hypotenuse is always going to be the longest side, that is the hypotenuse. So let's say this is 8. Let's say this is 6. All right. And now we are going to try to solve this for the hypotenuse. Okay. So this is A, this is B, and what is C going to be? All right, so now what we're going to do is we are going to take A squared. So A squared is going to be 8 squared plus b squared, which is 6 squared, is going to give me what c squared is going to be. Because remember, it's the sum of the two squares will add up to the hypotenuse, okay? So now 8 squared, I get 64, plus 6 squared is 36, should give me c squared. And 64 plus 36 gives me 100 is equal to c squared. So in order to find c now, I will have to do the square root of 100. And I know that 10 times 10 gives me 100. So therefore, c is going to be 10. All right, so this measure is going to be 10, and that's how the Pythagorean theorem is used. All right, now let's find some measures in which maybe a or b are missing but c is given, and so how we can solve that one. Okay, so let's go ahead to another problem, and we are going to change this. All right, and so let's say we have 12 given to us over here, and I might give myself c is going to be 13. All right, so now we have to calculate what is b. Okay, so now I have a, I have c, but I do not have b, and that's what I need to calculate. Okay, so again, same formula. And I'm going to say a squared is 12 squared plus, I do not have b squared, so plus b squared is equal to, I do have c squared, which is 13. So 13 squared, I've written the equation out like this. Okay, so 12 squared, I get 144 plus b squared is equal to 13 squared is going to give me 169. 13 times 13 is 13 squared, and that is going to give me 169. And so now we are going to look at this equation, and we are going to use the subtraction property of equality. So I'm going to subtract 144 from both sides of the equation. All right, and this cancels each other out. All right, so I'm left with b squared is equal to 9 minus 4 is 5, 6 minus 4 is 2. So b squared is 25. And so in order to find what b is, I have to do square root of 25, because I need to know what times itself is going to give me b squared, and the square root of 25 is going to be 5. So b is equal to 5. This is equal to 5. All right, so that's how we calculate whether it's a, whether it's b, whether it's c. So let's do one in which a is missing. All right, so we're going to do a problem in which A is missing, but we do have B and we have C. All right, so let's say B is going to be 15. All right, and C is going to be 17. So what will A be? So once again, using this, again, substitute the values. I don't have a squared. I do have b, which is 15 squared. I do have c, which is 17 squared. Okay, so a squared plus 15 squared, 15 times 15 gives me 225. Okay, and 17 times 17 gives me 289. All right, so we have these squares over here. Again, using the subtraction property of equality, I am going to subtract 225 from both sides of the equation, and this cancels each other out. So I'm left with a squared. This is going to give me 9 minus 5 is 4, 8 minus 2 is 6. So a squared is equal to 64. So again, to find a, I need to know what number times itself is going to give me 64. So I'm going to have to find the square root of 64. And so therefore, a is equal to 8. So now this is my missing value. All right. So very simple to find the different lengths of the right angle triangle, whichever one is missing. And there are certain numbers which are Pythagorean triples. And basically, a Pythagorean triple is nothing but you have three positive integers that fully satisfy the Pythagorean theorem. All right. So that's basically, we've actually been working with the perfect integers that are satisfying it so far. And so there are certain triples that are actually going to completely satisfy this theorem. And some examples are like 3, 4, 5, which we have just done, the 5, 12, 13, 7, 24, and 25. You have 8, 15, and 17, 9, 40, and 41. Then you have 11, 60, and 61. So there are several of these that are actually Pythagorean triples, which give you the perfect answer when you are solving it. All right. So that's the Pythagorean theorem, and it pertains to right angle triangles.